All right, so we're gonna do a little bit more, just math in general. We'll start with different types of math. But we will do a lot of algebra based because that's really the foundation for a lot of other maths. But yeah, so just going off the basics, you have algebra, which involves, obviously letters, numbers, formulas, stuff like that. You have geometry, which involves lots of, shapes, size, and stuff like figures, shapes, and stuff like that. Then you have trig or trigonometry to be precise, uh, which involves like angles and shapes like that. Then you have calculus, which involves a lot of things called derivatives and integrals, which we'll get to later. And then you have statistics, which involves a lot of data in general. And then you have probability, which involves a lot of chance, such as what's the probability of raining and stuff like that. Yeah, I think, again, we won't do algebra first because there's a lot of foundational basics of that. So let's go right ahead with algebra, lots of algebra. All right, suppose you have r of x, a function of x, that's called r, and that equals x cubed minus 4x squared plus 4x minus 6. And you want to find out what r of 2 is. So we can just plug the right in because, that's how you evaluate a function at x equals 2. So that's 2 cubed minus 4 times 2 squared plus 4 times 2 minus 6. All right, so r of 2 should equal, that is not r of 2. So r of 2 is going to be 2 cubed is 8, 2 times 2 times 2 minus 4 times 2 squared is 4, plus 4 times 2 is 8, and this subtracts 6. So 4 times 4 is 16. So 8 minus 16 plus 8 minus 6. So let's see, 8 plus 8 is positive 16, and you subtract them this 16. Since all this goes to 16 minus 16, which is 0, so you're just left with negative 6 as your answer. And you move on. All right, you want to find out this problem. It's x minus 3 over 4 plus 2/3 equals 17 over 12. You want to solve for x. So let's subtract 2/3 because you can, and you should, because that equals 0 now, and then your left side is going to be all that, but let's do the right side. Right side first. 17/12 minus 2/3. You should get common denominator, so multiply this whole thing by 4, which is 1, which that's why the equality is preserved. But that will help us enable us to get us 17/12 minus 4 times 2 is 8, and 4 times 3 is 12, which is the whole point because you get common denominators. And then you get you could just subtract ordinarily. So you do 17 minus 8, which gives you 9/12 as your right side. So you're left with x minus 3 over 4 equals 17 minus 8, which is 9/12. Okay, and then this is much more simplified than before. So you can just do cross multiplication. That's the easiest way when you have equal signs in fractions. This and this. So you're left with 12 times x minus 3 is equal to 9 times 4, which is 36. Let's just do that. There's a couple ways to do this. Honestly, you could just divide by 12. That might make it a lot easier actually. So you're just left with x minus 3 is equal to 36 divided by 12, which is 3, I believe. It's in this at 3. So you're gonna left x equals 3 plus 3, which is 6. So your answer is 6, and you move on. All right. Suppose you have a function f of x equals 2 times 3 to the x. Only the 3 is raised to the x. That's important. And then you are adding 1 to it. So you want to find out what f of 2 is. So again, you just plug it right in because that's how you validate a function. This function at x equals 2. That's a 3. That's 3 squared essentially. You could just, let's write that again. F of 2 is going to be 2 times 3. I could just leave the 2 outside. It's fine. So you do x1 at first. The 3 squared is 9. And then you do the multiplication first. So then you have 18. You add 1, and you get 19 as your answer. And you move on. All right, this is a little bit tricky because it involves factoring, but we'll get to that. Okay, let's just add this to, get one side. It's not necessary now. X plus 4 squared. 7 plus 2 is 8, 9. And then let's just do the x plus 4 squared. That will turn into, this is a trick. You could do x squared plus 4x, but you do it twice because when you double distribute, it's called, because this is the same thing as x plus 4, x plus 4. And you do this, 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 and this. And then, so you eventually end up getting x squared plus 8x plus 16 equals 9. And then you could just do, let's see, you could just do 16. Let's just get everything to one side, or 0, I meant. So you could do 16 minus 9. Minus 9 to get the right side equal to 0. So you get 16 minus 9, which is 7. So you're left with x squared plus 8x. Oops. X squared plus 8x plus 16 minus 9, which is 7. And that is equal to 0. Now you can do factoring. What two expressions will give you basically this value? So x and x, because when you do that, it will give you x squared, which is good. That's what we want. And then we do, the trick is to find two numbers that when you put in here and here with the signs as well, it will multiply to give you this number and add to give you this number, essentially. So that is 7 and 1, and both are, everything's positive, so you can do it positive. So let's try it. Let's just check, because we can and we should. X times x is x squared. X times 1 is x. 7 times x is 7x. And 7 times 1 is 7. And that equals x squared plus x plus 7x is 8x plus 7, which is exactly what we want. So these are actually equivalent, which is nice, which it should be. And that's equal to 0. So now that we have x plus 7 and x plus 1 is equal to 0, we can just use the 0 property and just set each one of them equal to 0, because that's when the entire thing will be equal to 0. So x could equal negative 7, or it could equal negative 1. So your answer is x is going to be negative 7 or negative 1. And that's it. And you move on. All right. Let's do this. So formula for volume of a cone, it's just a fact for a general cone. V equals volume equals 1/3 pi r squared h, where h is the height, r is the radius, pi is the constant, pi, and v is the volume, pi r squared h. And we want to just solve in terms of variables for h, in terms of the other variables. So no numbers, we just solve for h. So this 1/3, let's just get rid of it because it's really annoying to work with fractions. So multiply the entire thing left and right by 3. So you get 3v. It's going to be 1/3 times 3 is just 1. So now you get rid of that fraction. And you're just left with pi, that's pi, r squared h. And you could just divide that by pi r squared. And you're just left with h. So h is going to be 3v equal over pi r squared. That's all we're looking for. Again, no number to solve for how you solve regular equations. All right. Let's do this. 4/3 equals x plus 10 or 15. All right, let's do cross multiplication again. So you have this and this. So then you have 15 times 4. So that would be 60 equals 3. I'm not going to distribute because it will be easier actually, but you could, and you'll get the exact same answer. But 3 times x plus 10, just divide by 3, so it makes it much easier, because 60 divided by 3 is just 20. So you're left with 20 equal to, this cancels out, x plus 10, and you can just subtract 10 from both sides. So x equals 20 minus 10, which is 10, which would be our answer. and you move on. All right, another function. So g of x is going to be negative 4x squared. Notice that the negative is not part of the x squared, otherwise it would always be positive. So the negative actually does matter, because it's not this. This would be just positive always, but that's not what we're dealing with here. So you have negative 4x squared minus 3x plus 2, and you want to find out what g of negative 2 is. All right, let's do it. Just plug in negative 2 as well, because that's what the function at this function at x equals negative 2 equals. So this is tricky, so do it very slow. The x you're replacing with negative 2. So this entire thing is inside. That's raised to 2. That's important. And then do minus 3 times minus 2 plus 2. All right. Okay, negative 2 squared, that's just 4. This whole thing is just 4 because it's negative 2 times negative 2 is positive 4. 4 times negative 4 is negative 16. All right. Okay. Negative 3 times negative 2 is just positive 6. And you're just adding 2. So that's about it. So 6 plus 2 is 8. So negative 16 plus 8, which is obviously negative 8, which is your answer. And you move on. All right, let's solve a little bit more equations. Yeah, let's solve a little bit more equations because that's fun. Let me write it down. Oops, that's supposed to be x squared. This is, by the way, a second degree equation. It was a quadratic equation because it's essentially because it's x squared in it. You look at the highest exponent value for the degree usually equals 0. All right, we want to solve for x. Remember, there should be 2 because you're going to end up finding 2 values that can equal. A simple analysis is that you can have either a negative or a positive, and they both are satisfied because anything squared will be a positive. So you will definitely have more than one answer, most likely. Okay, let's just add 42. So you have 6x squared equals 42 divided by 6. X squared is equal to 42 divided by 6 is 7. Take the square root. So your answers, remember it's answers, because when you take square root, you get both positive and negative. So x is going to be positive or negative square root of 7. And that's the exact answer that we're looking for. We don't have to do anything further. You can even simplify that. So that's about it. All right. All right, this is just asking, let's just do an example where it's asking for a property we use. Suppose we went from p squared plus 5 equals 8p minus 7, and we went from this to this. P squared plus 12 equals 8p. And they suppose they want to know what property is used or something, because something changed. But what changed? Well, it seems like they just added the 7, because 7 plus 5 is 12. So what property is that? Is it the associated property? No, because associated property is in the parentheses, you're doing in different places, and so that has nothing to do with it. Commutative property? Not really, because it has to, like, I don't know. You could change the numbers around. 7 plus, instead of 7 plus 5, you can have 5 plus 7. So that doesn't really make sense here. Distributive property? No, because that's like this. You can distribute to 2x plus 4, essentially. So that's not it. It turns out this property is just very simply the addition property of equality, because you're adding, and you're adding the same amount on both sides in order to preserve this equality. So that's your answer. All right. Okay, let's do some more algebra. Negative 2/3. This is tricky, but not tricky, it's just a lot of fractions, which, again, you can always try to get rid of fractions. That's one trick of these problems, usually. Plus 2/3 x equals negative 5/4 x plus 2. All right, let's see. I can think of eliminating fractions. Turns out 12 is something they're all divisible by. So I'm thinking we could just divide by 12 to all of them. All right, let's distribute this first though, because that's my messed up. Negative 2/3 x, and then negative 12 times 2 is 24. So 24 divided by 3 gives you 8. So that will be negative 8. Just negative 8, because 12 times 2 is 24. So negative 24 divided by 3 is just negative 8 plus 2/3 x, it seems like. Huh, interesting. Yeah, that's why you should always distribute, because now these things will cancel out on the left side. So it's actually just get rid of it. Why not? Negative 2/3 x, positive 2/3 x, get rid of it. So you're just left with a much simpler equation, I guess. Negative 8 equals negative 5/4 x plus 2. And now you can just, that's supposed to be a plus, subtract 2. So yeah, negative 8 minus 2 is negative 10. So you're just left with negative 10. It's going to be negative 5/4 x. So let's just actually just times it by -1 to get both of them positive, honestly. So you're just left with 10 is equal to 5/4 x instead of negative. And now you just multiply both of them by 4/5 because they're reciprocal of 4/5. Because 4/5 times 5/4 just becomes 1 on the right side. So you're just left with x. You're just left with x equals 4/5 times 10, which is 10 times 4, which is 40, divided by 5. Yeah, because it's 4/5. Okay, 4/5 times 10, which is 40 over 5, which is 8. So your answer is 8, and you move on. All right. 5x squared equals 180 divided by 5 divided by 5. 180 divided by 5. It should be divisible. You end up getting 36. It's just math at that point. X squared equals 36. Take the square root. And x equals positive or negative 6, because 6 times 6 is 36. And there's 2 because you take the square root, you get positive and negative versions. So you get a positive and a negative, and that's your answer, and you move on. All right. That's, I think, a good amount for algebra for now. Let's move on to a little bit of geometry. And by little, I mean like one problem. All right. Let's suppose this is a triangle. Oh boy. Suppose that's a right triangle. And suppose it's actually 2 right triangles. So this is like a straight angle. This is A, B, P, let's call it D. Let's call that D. Let's put angles. That's 30. That's 45. That's the length is 8. All right, that did not help, but yeah, that's 45. 45 degrees, 8. That's the length of AP segment. Okay, so we want to know what the angle BAP is. BAP, which is this thing right here. Not this entire thing. You have to be careful. Just this thing. Oh boy. It's basically this. It does not go. That's not it. That's not it. All right. So we know this is 90. We know all those angles in the triangle should add up to 90. So this is 30. So you do 90 plus 30. Right. So you get basically plus x, which is suppose this, and that all equals 180. So 90 plus 30 is 120. Basically, I have 120 plus x equals 180. So 180 minus 120 should give me the angle, which is 60, which makes sense. So this equals 60 degrees, and you move on. It's very simple geometry problem. All right, that's enough for that. let's do a really quick trigonometry example. This is just a lot of formula based. This thing called SOHCAHTOA, which is basically the foundation of trig. It means sine is opposite over the hypotenuse. That's why it's so. Ka is cosine, is adjacent over the hypotenuse. Adjacent over the hypotenuse. And toa is tangent, which is equal to opposite over the adjacent. And so suppose that's x, that's 11, that's 8. Remember, this is what you use it when there's a right triangle. You can use trig, and it's all that to make it easy. Okay, let's solve for cosine of x. Okay, that's adjacent, which is this. We actually don't really know this, so, but it's a right triangle, so we can use something called Pythagorean theorem to find that side first. We have x, that's a right triangle, which you need, 11, 8. Pythagorean theorem says a squared plus b squared equals c squared. So this is a, this is b, this is c. All I know is that a and b are like switchable, I guess. C is not because that's hypotenuse. Okay, so we go from a squared plus 8 squared equals 11 squared. So basically a is going to be the square root of 11 squared minus 8 squared. And let's see if that gives a nice answer. 121 minus 8 squared. 8 squared is 64. So 121 minus 64, it's about 57, which doesn't really help, like in terms of nice numbers, but we can still use it, no harm in that. And now once we have that, we just plug in. Yeah, so it's the square root of 57. So cosine is adjacent, which is what we just found, square root of 57. And divided by hypotenuse, which is 11, and that's your answer. That's a number, and that's fine. And you can do the other ones as the same. It's just plugging in into the appropriate trig identity or formula. All right, that's that for trigonometry. Let's do a quick calculus example. Suppose this is a graph. Oh boy. All right. All right. So I'm just gonna do a really simple one, honestly. Suppose the point right here point is basically right here. It's y equals 3. So what's the limit and x equals like 2 or something? What's the limit of at x equals 2? The answer is just 3, because limit is basically if you push from the left, you push from the right, and you converge on one thing and it exists. There's like 3 different rules for limits, but we'll get into that later. But in this case, the whole graph is continuous, which means it's, there's no breakages in graph like this, something like that. There's no breakages, so continuous graph, which is nice. And then, so in this case, the limit is just 3. That's all. Which also means the left-hand limit is 3, because when you're pushing on the left, you're reaching towards 3. When you are pushing on the right, you're also reaching 3. Which means the right-hand limit is also 3, and they're both the same, which is helpful in a condition for the total limit, overall limit of 3 at x equals 2 to be 3. So the answer is 3. Okay, this is just using a formula. So it's asking you for the standard statistics now. Really simple. Standard error of sample mean. Standard error of sample mean. And standard deviation, which is represented by sigma, it's called, is 20. And n is the number of size of the sample, I meant. which in this case, suppose it's 25. And in this case, there's a very simple formula for actually finding the standard error of the sample mean, which is, this just means like the x bar is like the average, like the mean, essentially. This is basically it represents that. So you do sigma, and the formula is just sigma over the square root of n. So sigma is 20 over square root of 25. So it's 20 over 5, which is 4. So that's your standard error of the sample mean. That's all. It's just this formula. That's about it. Let's do probability. You have this. Break it up. Let's give them red. What is this? Yellow. The whole thing is filled up. Green and blue. They're all, it's filled up. It's like a quarter, essentially. Not essentially, it is. All right, what's the probability of red? This thing. Well, probability of red is just 0.25. It's a quarter. It's a quarter of the circle, basically. Let's do green or blue. That's tricky. So in this case, when there's an or, you just add the different probabilities. The probability of green is 0.25 plus the probability of blue 0.5. So total is half. And that makes sense because you can either get a green or blue is like half the circle, essentially. So it's half the probability. But what is the okay? So, but suppose what's the probability of green and blue? Now it's a little bit tricky because it's, you can't just add them. You actually have to multiply them. When it's and you multiply most typically in probability. So red, we could also do red and yellow, honestly. So we just, and since the probabilities are all of each individual one, it's like a quarter. So this will be 0.25 times 0.25, which is 0.0625, around like 7%, essentially. All right, that's that. Let's do a bit more. Probability of not red. Let's do that. Not red. Well, that's everything, you know, it's like all these three, which is 75%. And that's exactly what the answer is. All right, and probability of pink. Let's do that. Well, that's 0. There is no pink in there, so it's impossible to get a pink in a logical world. If there's no pink, you're not gonna get a pink. So yeah, those are just simple examples. There's not a lot of, you know, crazy things with probability. It's just a number. The total, like the number you care about, divided by total in essence, which is the basics of probability. All right, let's go into a couple of last concepts, which is LCM and GCM. Least common multiple and greatest common factor, actually GCF, not GCM. All right, let's do LCM, which is least common multiple. It just basically, you list out the multiples of, if it's, I'll just do an example. It makes a lot more sense. So if it's LCM of, say, 4 and 10, you want to find the least common multiple of 4 and 10. So the easiest way to do this is just list the multiples of 4, list the multiples of 10, and at least a good amount, because they're basically infinite if you keep multiplying them. And find the least one. Notice you can't really find the greatest one because you know, you can keep going on forever for multiples like 4, 8, like 4, 8. Note that the 0 really always, but like that's kind of trivial. It doesn't really help with that because everything can essentially be 0. At least one of them multiple. So that's 4, 8, 12, 16, 20, 24, and so on. This goes on forever, so you can't really have the greatest common multiple, as I mentioned. I'll just put in 0, why not? 10, 20, 30. I see something. I see 20. Right here and right here. And that's the least one. So that's your answer. Least common multiple of 4 and 10 is 20. All right, let's do more. This is just fun math. Or, yeah. 6. So, oops, that's 0. Actually, I will drop to 0 because it's kind of trivial for now. But 6, 12, 3 is 18, 4 is 24, 5 is 30, 36, so on. 15, 0, 15, 30, 45, and so on. I see something though. I see a 30. Yep. And that is your least common multiple. That is true. Nice. Okay, now let's get trickier a little bit, maybe. 4, 6, and 8. Let's do 3 of them. It's the same concept. You list all 3 of them and find the, the least common for all of them. So 4, 8, 12, 16, 20, 24, 28, and so on. 6, 12, 18, 24, 30, I believe. Yep. We'll keep going on and so on. 8 times 16, 3 is 24, 32. I see something. Ooh, look. 24, 24, and 24, and that is the least common multiple. That is true. That's how you do it. Let's do a little bit more. 21 and 6. That's trickier. All right, you got 0, essentially. 21. I believe 42. I'm going to see, because this is a really big number, so let's just do the other one actually first. I don't know why I put 0, but that's fine. 6. Yeah, 6, 12. 3 is 18. Because you're really up to 42 there, so you want to, do the smaller number first. 6 is 18. 24, 30, 36, 43. Ooh, look. And that pays off. You don't have to go crazy. It is 42, the least common multiple. All right, let's get into the greatest common factor, GCF, also known as. Let's do an example. 25 and 30. So you basically, again, list the factors now of 25 and 30, or whatever numbers you want the GCF of, and you find the greatest one, because you can in this case, because the factors are limited, they're not infinite. Okay, I will do this. So 25. 1 times 25, so you can put 1 in 25. 2 does not go into that. 3, 4, 5 can go into it, because 5 times 5 in essence. And 6, 7, 8, 9, 10. Yeah, that's for now, that's fine. Let's do 1, 30. You could do 2 and 15. Yep. 3 can go into it, 3 and 10. 4 and unnecessary, 5 and 6. And yeah. Well, I already see 1. So let's just, yeah, look, 5 and 5. That is the greatest one. Yeah, that's common at least. So yeah, that's your answer. And you do that for the other ones, and that's about it. Okay, 1, 60, 2, 30, 3 should be 20, 4, 5. Yep, 5 can go into this. 60. Actually, yeah, 5. Okay, well, 4 also can go into it. I just realized. 4 and 15 times 4 is 60. And 5 can also go into it because of 10. 60 divided by 5 will be 12. So 12. That's a good amount. 100 is a popular one. So 1, 2, 100, obviously. 50. 4. I think 25 times 4 is 100. So you could do that. 25. 5 times 20. Let's see. I think I see actually the answer. Yeah, see the answer actually. 20 is a pretty big number, and if we do more, it will turn out it's 20 is the greatest common factor. But That's fine. You should still check all the factors though. But I know 20 will be the right one here. Okay, 75 and 30. All right, 175. 2 cannot go into it. 3 can. 25. 4 cannot. 5 can. 15 and 5, 6, 7, 8, 9. That's fine for now. 1, 30, 2, 15, 3, 10. 5, 6 and 5. What else? Okay, as it turns out, it will be 15. That will be the correct answer. That's 15. Yeah, that'll be that. Okay, let's do last one. It's just very systematic. So 1, 65, 2, no, 3. I don't believe so. Nope. Definitely 13 and 5. Okay, 1, 2, 20, 3, 4, 10. 5, 8. And as it turns out, it will be 5. Yeah, it will. The greatest common factor will be eventually 5. Yep. And yeah, that should cover it. Okay, just a quick facts to display. So circumference of a circle, which is like 2D essentially circle. It's not a sphere essentially. So circumference of a circle is 2 pi r. Circumference, which is basically the thing around it. The area, which is like everything inside the circle, is pi r squared for a circle. This is all for a circle. Okay, and then the sphere, which is like 3D circle, right, if that makes sense. The surface area, so basically, yeah, surface area, so like basically this will be 4 pi r squared, where r is the radius and everything. Okay, and then this area of this thing, so you actually just shit it in. Oops. Yeah, you just shit everything in. The area of a sphere is 4/3 pi r cubed. Yeah, that's just some facts about spheres and circles. And that will cover a good chunk of some basic math that we have done. A lot of algebra because, that's, again, it's a very foundational skill and it builds on everything. But yeah, thank you for watching and we'll see you soon.